Well, hello and welcome everybody to this surprise training I thought I would do. Actually decided yesterday to do this surprise training. Here's the reason. You might have already seen that I'm doing a big, massive marathon training session as I do every year the day after Thanksgiving, what we call Black Friday here in the US. And I'm doing another one on Monday, what we call Cyber Monday. And I'm trying some new streaming software this year with a different chat interface, trying to streamline things just a bit and make it a better experience for everybody. So I thought, you know what? I want to test it. Why not go live and teach some really valuable content while I'm testing it? So while this is a test and I might have to periodically say, okay, let's pause and let me go check something, make sure it's working, I've got some great content for you today. What I thought we would do today is a very collaborative exercise. I've got three topologies for you. I've got three routing topologies running different routing protocols, and they've got problems. And I need your help to get me to get these networks up and going again. So I'm going to be asking you as we go through these together to start chatting your answers in. To say, all right, Kevin, give this command, give the show IP interface brief command, for example, or do a show IP protocols command. And students have always enjoyed this. This is a great way for us to not just watch passively, but to be actively engaged in the troubleshooting process. So I am super excited for this. My guess, time-wise, it's probably going to take about 45 minutes, just a guess. And we're going to start off really simple. I know I hear the groans now. We're going to start with RIP. Yeah, I'm starting with RIP, not because RIP is a cutting edge protocol that we all need to know, but it's simple. It's going to be a way for us to kind of get our feet wet and get the momentum going. Get the momentum going for our troubleshooting. And then we'll go into some more real world applications, such as troubleshooting an OSPF network or troubleshooting an EIGRP network. So this presentation isn't for somebody that's brand new to IT. If you don't know what these acronyms mean, this might not be the webcast for you. But if you're familiar with doing a little bit of troubleshooting with RIP, OSPF, EIGRP, yeah, you're in the right place. And as an incentive to stick around to the end of the session today, I've got a downloadable resource for you. It's a zip file. And in that zip file, I'm giving you graphics of the topologies that we're using today. And I'm giving you the .yaml files. So if you're a Cisco Modeling Labs or a CML user, then you can take those YAML files and simply import them into your copy of Cisco Modeling Labs. If you don't want to pay for Cisco Modeling Labs, I've got a video out on YouTube. Just search for Kevin Wallace CML, and I show you how you can go out and use CML in the Cisco DevNet Sandbox for free. So for free, I'm giving you these topologies, and these topologies are already pre-configured, and they already have those issues, those errors built into them. And you can practice later with just kind of exploring around and say, how's another way I could have found that? So that's coming up at the end of class if you'll stick around. But let's get going, shall we, with RIP troubleshooting. And here's the topology that we're going to be working with. We've got a PC, and it's a Linux box. And we've got a server, also a Linux box. And we're going to, well, let me give you the rules here. We want every router, we've got routers R1, R2, and R3. We want every router to see every network in this topology. So let's see, how many networks do we have? We've got the network between the PC and R2, the network between R3 and the server. We've got those three networks interconnecting. I think we've got 5 networks. So these routers should each see 5 networks, and I want my PC to take an optimal path to get from itself over to the server. So let's get into this, shall we? I'm going to take my face off the screen, so we'll have a little bit more real estate, and you can see the print just a little bit better. And here is the topology that we're going to be working with. Now let me get us started. And here's another rule that I have for you. We are not allowed to do a show running config or a show startup config. I want us to get in the habit of instead of just saying, let me look at the config and see if anything's wrong, I want us to get in the habit of interpreting show command output. That's what I really want us to do. So we're going to give only show commands until we identify a problem, and then we'll fix the problem. But let's just start here on R1. We said that every network should, or every router should know every network in the topology. Let's see if R1 does that. If I say show IP route on R1, what do you think? Go ahead and chat it in. I'm looking at the chats right now. By the way, there's about a 15 to 20 second delay in the chat from the time I speak something to the time you hear it. So I don't see your response immediately. And as I'm doing this streaming test, I'm actually streaming simultaneously right now to a private Vimeo embed on my website. I'm streaming to YouTube. I'm streaming to LinkedIn. I'm streaming to Facebook. So I've got multiple chat interfaces up in front of me right now. And hopefully I've killed 15 to 20 seconds and we can start seeing some of the responses coming in. But tell me if you would. You see any issues here? Does R1 meet the criterion? Does it see all the networks? Or are we missing something? What do you think? Do you see any issues? And we must still have a little bit of a delay because I'm not seeing any responses coming in just yet. Am I missing a network? If so, what network am I missing? Well, that's almost a trick question, isn't it? I'm saying, are we missing a network? I think the networks are present, but take a look at this one. I've got this 10.0.0.0/8 network that I've learned via RIP, so we know that RIP is up and working. But yeah, Andrew joining us on YouTube is saying, yeah, we're missing some of the .10 networks. Yeah, that's one of the things that RIP does. RIP is going to do auto summarization. So if we have subnets that are part of the same classful network, it's not going to show us by default those subnets. It's going to show us the classful network. So from the perspective of R1 up at the top, it says if I'm going to go to maybe the server, it says I'm going to go to 192.0.2.2 as my next hop. Well, that's R2. So I'm going out of my way down to R2, and then I would go over to R. In fact, let's just try it. Let's do a trace route. Let's do a trace route to the server, if I can even get to it. Can I get to 10.1.2.200? I can, but let's follow that trace route. It says my next hop is 192.0.2.2. That's R2. My next hop is 203.0.113.2. That's R3. And then the final IP address, 10.1.2.200, that's the server. Okay, I got from R1 to the server, but instead of just going directly to R3 and out to the server, I took that little shortcut around R2. So we've got one issue that I think we've defined, and Andrew was the first to articulate that. We are missing some of our subnets. Before we go in and fix that, remember we've also got this other issue of sort of a suboptimal path going on. So you tell me, what command would you like me to give to try to fix this? It looks like both of my 10.networks, my subnets, 10.1.1.0/24 and 10.1.2.0/24, it seems like they're not showing up individually in R1's routing table. They're showing up as their classful network. The issue is we have discontiguous subnets of the same classful network. How do you recommend I fix that? What would you recommend I do to resolve that issue? Any suggestions? Yeah, Crypto Packet Zero on YouTube is saying, well, what if we go in and say no auto summary? Because like I said, it's going to do summarization to the classful boundary by default. I like it, Crypto Packet Zero. So let's do that. I'm going to go into R1 and I'm going to go into my RIP configuration, router RIP we'll say. And I'm going to say just as, and also Mosen, if I'm pronouncing that correctly, is saying also no auto-summary. Awesome. So I gave that on R1. I should probably do the same on all routers. I think you would agree with that. So I'm also going to go to R2 and let's do the same thing. I'll say router rip, no auto hyphen summary. And let's do the same thing on R3, shall we? Make sure I'm on the right. I've got lots of topologies going here, so I've got lots of little tabs. I want to make sure I'm in the correct R3. Let's go into router rip. I'll say router rip, and we'll say no auto hyphen summary. And some of the routes might stick around for a bit, even after I do that. So just to speed things up, here's what I'm going to do. I'm going to say I want to clear out my IP routing table. I'll say clear IP route star. Clear everything out. I'll do that on R3. I'll do that on R2. Clear IP route star. And let's do the same thing on R1. And then it will just rebuild its routing table. Clear IP route star. Okay. I think hopefully we're good right now. Let's go revisit we're actually on R1. Let's see if those two individual subnets are going to show up instead of that composite subnet we had before. So let's say show IP route. Oh, we just haven't given it time to learn, I suppose. Let's try again. There we go. Much better. I think you got it. Look at this. We now have the individual subnet showing up. 10.1.1.0, 10.1.2.0. That is great news. The bad news is I'm only seeing one path to reach those subnets. It says we're going to go to 192.0.2.2 to get to both of those. If you look at the topology, it seems to me like if I'm going to 10.1.2.0 where the server is, looks to me like I should go down to R3. But it's saying, no, if you want to get there, you got to go to R2. It's almost like we're not communicating between R1 and R3. Are they exchanging routes? I don't know. Let's see. Let's go over to R3 and see what's up. Over on R3, I'm going to do a show IP protocols command. Let's make sure we're running RIP here. We are running RIP, and I'll give you a moment to take in that output, and then I'm going to go give a similar command over on R1. Again, what we're troubleshooting right now is how come R1 and R2 are not exchanging route information? That's what we're trying to figure out. So let me give you a second to look at that. This is our, R1 and R3. This is our R3 output. Let's go to R2. R1. I keep saying those backwards. If I go over to R1, show IP protocols, there's its output. And what I'll do is I'll let you look at this for a moment, and then I'm just going to toggle back and forth between R1's output and R3's output. And if you notice an issue, type it in. I'm looking at all the different chats right now. Go ahead and chat it in. So there's R1. There's R3. R1, R3. Anybody notice an issue? Giving a moment for anybody to chat in. Yeah, Steve on YouTube is saying, and also CryptoPacket0 says that, and so is Julio, saying we have a RIP version issue. Oh, I see what you mean. Right now it says we're sending and receiving on all these interfaces. We're sending and receiving RIP version 2. If I go over to R1, it says I'm sending R1 on my interfaces and I'm receiving both on one interface, but I'm only receiving 1 on the interface going out to R3. So yeah, I agree with you. I think what the deal is, R1 is trying to communicate with R3 using RIP version 1. R3 is trying to communicate with R1 using RIP version 2. That's not going to work. And since we're big fans of RIP version 2, we should probably go turn that on R1. Let's go into global configuration mode, and I'll say router RIP, and we'll say, let's turn on, shall we, version 2. Now, is that alone going to do it? I don't know. Let's do another show IP protocols. Huh. That looks better, but look at this. It says I'm still just sending and receiving on version 1. So when I said use version 2, that didn't seem to fix things, did it? Why didn't that fix it? Anybody have something else that I should go check out? I mean, clearly, many of you spotted it. We had a version mismatch. Big red flag. But I went in and I said, okay, run version 2. Let's match. And I'm still not running version 2 on this interface. What should I do now? Any ideas? Well, something that we can do to affect what version we're using is not just in router configuration mode, it's in interface configuration mode. What if I went into the interface that's not playing nicely, and I explicitly tell that interface to use version 2? So on router 1, let's go into our problematic interface of gig 0/2, and I'm going to say RIP, our IP RIP, receive version 2, and IP RIP send version 2. Let's see if that makes a difference. If I look at my show IP protocol output again, oh, that's looking a lot better. Look at that. It's all 2s now. I'm optimistic. This looks encouraging. Let's see if R1 now has more information in its routing table. If I do a show IP route on R1, oh, this is a lot better. If I want to get to the 10.1.2.0 network, let's see. Yeah, I'm going to go to 198.51.100.2. That's different. It used to tell us to go to R2. Now it's saying go to R3, which I would agree with. So I think that issue might be resolved. We now seem to be, and I would do, unfortunately with RIP, unlike OSPF and EIGRP, we cannot look at our neighbor information because we don't form neighborships. But it sure looks like I'm communicating between all of our routers. But remember, there was one other criterion we had for this lab, and that is when the PC goes to the server, I want it to take an optimal path. So I'm going to go into my PC. By the way, you might just want to make a note if you're downloading the YAML files that I give you at the end of this. You're going to be logging into these Linux boxes with a username and a password of Cisco. So it's going to be Cisco. Now, on some YAML files that I've done, I don't think that's the case here. But if it's not Cisco is the username password, it's going to be KWTrain, KWTRAIN for both the password and the username. But I think this one is just, in fact, let me log out. Let me exit. Let's see, Cisco. Yep, that works. And I loaded this up using the same YAML file that I'm giving you. So yeah, that should do it. Oh, Taher is asking when the next session will be. This is just a surprise session. The really big session happens on Friday at 2 p.m. Eastern Standard Time. Eastern Standard Time is currently 5 hours behind UTC or GMT time. So it's going to be 2 p.m. on Friday, and it's going to be a massive marathon session. And I'll talk more about what we're going to be setting up in that in just a moment. But get back to our story. Let's see if we're taking an optimal path. I'm doing a trace route to 10.1.2.200. That's the server. Can I get from the PC to the server? I made it to the first hop. Second hop. And then I'm to the server. But let's go through this. My first hop was 10.1.1.1. That's R2. My next hop was 203.0.113.2. That's R3. Then my final hop was the server itself, 10.1.2.200. My question to you, look at the diagram carefully before you answer. Is this an optimal path? And if not, why not? Did this PC take an optimal path to the server? I'm about to teach something that I would bet that 9 people out of 9 in this group have never heard of before, or maybe 9 out of 10. But it's a very, very unknown feature when it comes to RIP. It's kind of stuff I had to get into back in the day when RIP was actually on the CCA blueprint back when I took the lab. But what I'm getting at, and Federico has pointed it out, that link between R2 and R3 is a 100 meg link. Everything else is a gig link. Why are we not using the faster links? Because RIP's metric is based on hop count. RIP pays exactly 0 attention to link speeds. So, yeah, that's what RIP is doing, what RIP does right here. Now, here's the issue. Can we fix it? Is there a way to make RIP look at that one route or that one link between R2 and R3 as being less attractive? I think there is. And there's different ways of doing this, by the way. I'm going to be using something called an offset list. This offset list can say, whenever I receive an advertisement on this interface, I'm going to add 10 to it. Whatever the hop count is, I'm going to add 10 to it. Whenever I send a RIP advertisement from this interface, I'm going to add 10 to it. So I'm almost, poisoning isn't really the right word, but I'm artificially inflating the hop count number just because I know it's a less attractive path. So here's how we do that. And again, I bet most people have not seen this one. And I can do all of my work on R2. Let's go into R2 and I'll say router RIP. And here's the syntax. I'm going to say offset list. And we could say what networks I want to apply this to. I'm just going to say 0 for all networks. And I'm saying when I receive an advertisement coming in and says the metric to this network is 2. Well, I want to add 10 to that. So coming in, I want to add a metric value of 10 to anything coming in gig 0/3. That's the interface going over to R3. Let's do the same thing, only when I transmit, when I advertise metrics. I'm going to add 10 in the outbound direction. Now, to make this take effect, again, I've got to go around the ring here and clear the IP routes just to speed things up a bit. Clear IP route. And finally on R3, clear IP route star. Okay, now let's take a look at the routing table on, let's go to R2. On R2, if I do a show IP route, it looks like I'm now preferring to use the gig up to R1 to reach the server. The server is on the network of 10.1.2.0. And here, let me see if I can highlight that. Here it is. 10.1.2.0. It says I want to go via 192.0.2.1. That's R1. So now instead of taking the least number of hops, because we artificially inflated that metric, we're going to go to R1 instead. Nice, nice. And R3, by the same token, should prefer that to go to back to the PC. Let's go to R3, and I'll do a show IP route. And if I'm trying to get to 10.1.1.0, it says my next hop is 198.51.100.1. That's R1. So you see what we're doing? By artificially inflating the hop count in those advertisements, we are bypassing that 100 meg link and using the gig link. Now, if a gig link went down, I mean, that other link is still there. It will after convergence happens, it will still work. But I think we have success with our RIP troubleshooting, and I got to tell you, this group did an amazing job. We didn't stump you on anything, so excellent work, everyone. Now, before we go into our next option or our next troubleshooting task, I want to tell you about this training that I've been hinting at that's coming up on Friday. On Friday, I'm trying to get people ready for 2023. In other words, I don't want you to get to January 1st on 2023 and say, well, I guess I need to set some goals for the year and I really need to get going on those. No, right here at the end of November in 2022, I want you to set those goals now. That's really our focus on Friday and then again next Monday, where we're going to be saying here are 4 different technical domains that I think you should be spending time in. And we're going to be giving you lots of demos. One demo that you've probably never seen me do before. I'm trying to include a lot of new demos in these. I've really been working hard on these presentations. I think you're going to love the training if you can join us. But I'm going to be demonstrating this network. I'm going to show you how to set up an MPLS network. We're also going to be talking about Amazon's AWS. That's a skill that's very much in demand. We're going to start with no Amazon AWS account at all. I'll show you how to add that, how to create an administrative user using their IAM service, show you how to set up a Linux server for free, by the way. We're going to be using the free tier for all of this. We're going to set up a Linux server running in the Amazon AWS EC2 service, which gives us a virtual server. Then we're going to install the Apache web server on that, and I'm even going to go edit that web server. So starting with not even an Amazon AWS account, we're going to create a web server in the cloud for free. That's really cool stuff. So I think you'll want to join us for that. We're also going to be getting into network programmability. We'll talk about what software-defined networking is all about. And we're going to get into a tutorial to get you going on Python programming. And we're going to talk about REST, representational state transfer, how we can use APIs within devices or within network controllers, application programming interfaces, to send REST calls to those APIs to do configuration. Bottom line is, at the end of this demo, we're going to write a Python program that's going to go out and do a configuration change on a Cisco CSR1000V that I have running in GNS3. And we're going to be talking about different ways of getting hands-on experience with Cisco Modeling Lab, Cisco Packet Tracer, using real equipment, using something like GNS3. We're also going to talk about cybersecurity. And I just did a big marathon training session on security not just a few weeks ago. So I'll not spend as much time on that, but I'm going to show you a demo that you did not see in that security deep dive, and it's on wireless hacking. I want to show you within just a few minutes how I can sniff the airwaves. I can launch a de-authentication attack against a client. When that client re-authenticates, I can capture the four-way handshake. I can run a brute force attack against those captured packets. And literally within a matter of minutes, we're going to be able to crack that password that's on that wireless access client. And to get signed up for that, again, it's a 2-session training. I call it the IT Career Accelerator because I've identified, and I'll go through this on Friday, I've identified these 4 different domains that I think you really need to focus on. And we're going to be talking about each one of those. I'm going to be giving you an overview of certifications available in those different areas. I'll be making some recommendations about what your next step might be. But it's on this coming Friday, commonly known as Black Friday, and the following Monday, a week from today, which is commonly known as Cyber Monday. And it's from 2 to 5 p.m. Eastern Standard Time. Here's the link. Be sure to write this down. Take a screenshot, something. Do it right now. Go to kwtrain.com/2023 because we're making your plans or helping you make your own plans, what's right for you for next year. I have never been as excited about, I do this every year around Thanksgiving. I've never been as excited about what I got for you this year. There is so much goodness and coolness coming up that I just cannot wait to share with you. Just some crazy demonstrations that you've never seen me do before. So you got to join us for those if you would. And we'll be talking about how you can accelerate your career now so you're not starting from zero on January 1st. You're going to hit the new year with some momentum because you're going to start accelerating now. Again, go to kwtrain.com/2003 to get signed up. And just to kind of give you an overview of some of the things we're going to be covering, I already gave you a hint of some of those things. But yeah, I want to give you those 4 different growth areas. We'll talk about certs for enterprise networking. We're going to be something I didn't even mention. We're going to be doing password recovery on a Cisco Catalyst switch. We're going to take a look at certifications for cloud, and I'll make some recommendations about or give you some options of what you could do there. Lots of AWS configuration live that you can then go do on your own. Then on Monday, we're going to focus on network automation. We'll play with Postman. We use the Cisco DevNet Sandbox. I'm going to give you a Python tutorial. We're going to go out to GitHub. We're going to get a sample program. We're going to show you how we could alter that. I'm going to show you my CSR 1000V running on GNS3. We're going to apply that program. We're going to run it against the APIs inside of the CSR 1000V. We're going to make a configuration change. We're going to move on to cybersecurity. I'm going to show you how we can do, or how bad people would do, a wireless attack. And we'll talk about some cybersecurity certifications, how they are in tremendous demand today, and which ones you might go after. You see why I'm so excited about this training? It's going to be, I think, the best training we've ever done during our annual sales event. And speaking of sales, beginning tomorrow, if you're on our mailing list, you're going to start getting a deal of the day. We do our biggest deals, biggest discounts of the year this coming week. So if you want to stock up on some training to get you through 2023, now's definitely time to do that. Again, kwtrain.com/2023. Let's see if we have any questions. Oh, a lot of people chatting in saying that, yeah, cannot wait to be there, or I'm the same way. I cannot wait for it either. But tell you what, let's jump into OSPF troubleshooting now, shall we? Oh, I forgot. One other thing before we get, actually, I'll save that for afterwards. Let me show you that OSPF topology really quickly, and I'll come back to another little surprise I had for you. But here is our OSPF topology. And I'm going to, again, go out to the terminal where my face is not taking up screen real estate. And I need to move over now to my OSPF devices because I've got tabs open for RIP, for OSPF, and for EIGRP. Again, same rules here. I want every router. It's the same topology. I've just now assigned the interfaces to different areas. It's the same topology without using any show running config, show startup config, any debug commands. I want us to be able to have optimal pathing from the PC to the server where every router can see every network, kind of like it was before. In fact, we might want to get started just by seeing if we have neighborships established. Let's go to router R2 and let's do a show IP OSPF neighbor. It knows, oh, by the way, just to make the neighbors easy to recognize, I gave R1 a router ID of 1.1.1.1. Router R2 has a router ID of 2.2.2.2, and you guessed it, R3 has a router ID of 3.3.3.3. Wow, I'm already seeing one issue there. It says that I'm down. I've got a down condition going up to router R1. What do you say we troubleshoot that first? Does anybody have a command you would like me to type in, a show command? not showing the running config, but another show command that might give me some insight as to why I don't have a neighborship with R1. What command would you like me to type in? Go ahead and chat it in if you would. Any commands you would suggest? Well, the interface going up to R1 is gig 0/2. I'm really curious about the parameters on that interface. So I'm going to give a show IP, or rather, let's just do a show interface gig 0/2. I'll let you look at that output for a moment. You can see if anything raises any red flags to you. Do you see any problem with that? Give you a moment. Yeah, Albert and Paul, they both have suggestions. I'll give both of those commands. Those are great. Paul is suggesting we do a show IP OSPF topology. Let you look at that for a moment. And Albert says, let's do a show IP interface for gig 0/2. Okay. It's a lot of info right there. Did anybody see something that is suspicious? Mirko is saying, oh yeah, that MTU. Remember when we looked at that interface originally? Mirko was saying, yeah, that MTU, the maximum transmission unit, that's not standard. Can anybody tell me what the default maximum transmission unit is on an interface like this? It's not 1476 bytes. It's 1500 by default. And that's one of the things about OSPF neighbors. That's a requirement. The MTUs have to match. That's easy to do. Let's make it match. I'm going to go into global configuration mode. My OSPF process ID, by the way, is actually, I'm not even going into OSPF. I'm just going into the interface. Let's go into interface gig 0/2, and I'll say the MTU is the default of 1500. And to reset things, I'll say clear IP OSPF process. Yeah. And yes, I want to clear all the processes. Let's give it a few seconds to try to reestablish any neighbor relationships. And let's do a show IP OSPF neighbor command. Oh, look at that. That is so much better. Yeah, let's see, who was it that got that one? Yeah, Albert noticed it. Mirko noticed it. Tambir noticed it. Yeah, a lot of people noticed it. Great job. And a lot of people, I'm seeing somebody on Facebook. Let's see, it's Abhishek. I'm so sorry that I'm mispronouncing that. But you got the correct default MTU, as did a lot of people on YouTube. Excellent, excellent work. So that's looking really good. Let's just continue our journey. Let's keep walking around this topology and making things work. We're on R2 right now. Let's see what its routing table looks like. I'll do a show IP route. And I'm looking at this. I mean, that's a lot of routes. Looks pretty good. One thing I noticed though, well, let me ask you, do you notice anything that is a little concerning? Then I'll tell you what I'm noticing. I'm on R2. That's the one on the bottom left. And there is something that's concerning to me. Anybody else concerned about this? The topology is pretty much what we used with RIP. Remember with RIP, that link between R2 and R3 was 100 meg? Same thing here. All the other links are gig. So, OSPF just pays attention to bandwidth as it's making its path selection decision. And it's looking at that network between R1 and R3, the 198.51.100.0/30 network. You see that one between R1 and R3? And it tells me that there are two equal cost paths to get there. It says, yeah, if you want to go to an XTOP of R3, the cost to get there is 2. If you want to go to R1, the cost to get there is 2. That's not right. That should not be right. It's saying that the cost to get to R1 over a gig link is the same as the cost to get to R3 over a 100 meg link. Okay, what gives? Who can help me out with that? Why is it looking at those two very different interface speeds as having the same cost? Yeah, Nick's got it. Nick says it's the auto cost, or it's the reference bandwidth that's not working. You see, the way OSPF does its metric calculations is it says, we're going to take the reference bandwidth and we're going to divide by the interface speed. And the reference bandwidth by default is 100 meg. So the cost for a 100 meg link would be the reference bandwidth of 100 meg divided by the interface speed of 100 meg. 100 divided by 100 is 1. What if it was a gig link? Well, the reference bandwidth is 100 meg. The gig would be 1,000 meg. What is 100 divided by 1,000? It's 0.1. We cannot have a decimal number. We've got to round up to a 1. So the issue is, for link speeds of 100 meg and higher, the cost is the same for everybody. And that's just because this rule was developed many years ago before we had a lot of higher speed links. But yeah, a lot of people are now saying, let's set that auto cost reference bandwidth. And here's how we do that. I'm going to go into, we'll just start here on R2 since we're here. And I'll say for OSPF process ID 200, which just make it easy to remember, the process ID on R2 is 200, on R3 it's 300, on R1 it's 100. They don't have to match. But I'm going to say auto cost, reference hyphen bandwidth, and you'll notice the unit of measure is in megabits per second. Well, let's give 200,000. I'm saying make it 2 million meg. Oh, I'm sorry. I thought it was a 2 I gave. I gave a 1. Let's make it 2 million meg, which is 2 terabits per second. So we're going to be good until we exceed one day 2 terabits per second. And we want to give that same command on our other routers in this area. So I'm going to copy that. Let's go to R1. And for R1, I'll say router OSPF 100, and I'll just paste in that auto cost reference bandwidth command. Let's go to R3, do the same thing. router, OSPF process ID 300 in this case. All right, let's see if that fixed our issue. Let's go to R2 where all this mess began, and let's once again do a show. Let me back out of this. Let's do a show IP route. This time, R2 says if I want to get to 198.51.100.0/30, it only gives me one way to get there, doesn't it? It says, let me find it again here. Yeah, it says go to 192.0.2.1. That's R1 over a gig link. It now sees, oh, and notice the cost. It used to be 2 because we changed the way we changed the reference bandwidth. The cost is now 4,000, but 4,000 is going to be better than the 40,000 that we would have as a metric from R2 to R3. So I think we've accomplished that. That's great news. Let's make sure that everybody can see everybody and all of our neighbors can see one another. Let's start at R1 and just kind of walk the tree here. We'll go to R1 and I'll say show IP OSPF neighbor. Okay, I've got full adjacencies with my neighbors there. Nice. Let's go to R2. Show IP OSPF neighbor. I've got full adjacencies there. Also nice. And if I go to R3, show IP OSPF neighbor. I've got those adjacencies. So that looks good. However, there is something in the routing table that concerned me. Let me go back and revisit that. If we go back and look at, let's go back to R2. On R2, actually let's do this on R1. I think that'd be better. Let's do a show IP route on R1. Can it see everybody? Can it see all the networks? Can anybody identify a network that's not showing up here? I see one that's not showing up here, and I think that's a concern. What's a network that's not showing up for me? It's the network that has the server on it. 10.1.2.0/24, nowhere to be seen in a routing table. Now, can R3 see it? Excuse me, that was R1. Can R3 see it? It's directly attached. Show IP route. Yeah, it can see it, but it's because it's directly attached. So my question for you is this. Why can R1 not see that 10.1.2.0/24 network to which the server belongs? Yeah, Steve is reminding me of something that Max CY pointed out earlier, that we've got a discontiguous area. There needs to be a direct connection between every non-backbone area with the backbone area. So let's say a couple of companies merged. We're part of the big, one big happy, right now not so happy OSPF network. Area 2 needs to connect directly to the backbone area of Area 0, and it's not. It's connecting to Area 1. So tell me, do I need to go in and change out Area 2, make it something else, kind of redo all of my area layout? Is there something else I could do? Yeah, Albert's saying, and many other people are as well, I think we need a virtual link. And you're absolutely correct. This is a way to overcome that issue. If we have a couple of companies merge, we can create this virtual link. So I'm going to begin on R2. R2 in the lower left. Let's go into OSPF routing process 200. And I'm going to say area 1 virtual link, and I'm going to give the router ID of the far end. It's 3.3.3.3. Oh, by the way, a lot of people get tripped up on this. They are not sure what area to put in here. I mean, I'm trying to get to area 2. Would this do it? Or should I put in area 2 there? No. What you put in this area command is please write this down. It's the transit area. That's we're transiting area 1 to get over to the router ID of 3.3.3.3. So that looks good on R2. Let's go do the same thing on R3. Router OSPF, process ID 300. I'm going to say area 1, virtual link, and I'll point to the router ID of R2, 2.2.2.2. Yeah, I think that's it. Now, let's see if anything looks different from the perspective of R3. Let's do a show IP OSPF neighbor. And you'll notice I have 2 neighborships now. I've got a couple of neighborships with R2. One is via my physical interface of gig 0/1, and the other one is via this virtual link that we've created. So now, if I go back to R1 where I wasn't seeing that network earlier, and I do a show IP route, do I now see 10.1.2.0? I do. Look at that. So that fixed it for us right there. We just had to use a virtual link to overcome that. Now let's see if we truly are taking an optimal path now. Let's go over to the PC and let's do a trace route to the server, 10.1.2.200. And the first hop, it should be R2, and it is. Now, the next hop, we don't want it to use the 100 meg link. We want it to go up to R1, and we did. Look at that. It went to 192.0.2.1. Then we go back down to R3, and then finally we should go to the server. So I think we have now met all of the criteria for this exercise. Again, that was a fantastic job. So let's take a look in just a moment at our third and final exercise today. Before we do that, I did want to bring up a point that tomorrow begins our annual Black Friday, Cyber Monday sale. Again, I mentioned that it's our biggest discounts, biggest sales, biggest offers of the year. We've got more products this year. We've got more bundling going on. It's our best sale ever. Now's the time to stock up on some training for next year. And we're going to have a deal of the day every day. Day number 1 is tomorrow. But since you took time out of your day to show up today here on Monday, I thought I'd go ahead and give you a preview of tomorrow's deal of the day and let you have at it if you want, because I'll make it available to you right now so you don't have to wait. And here's the deal of the day. My very good friend, Anthony Sequeira, I talked to him this morning, in fact. He created just a masterpiece of a course that pretty much doesn't exist out there. You'll be hard-pressed to find an SP core class anywhere near the quality of Anthony's course. And this is a course that I'm actually licensing from somebody, which means I pay a license fee when you buy it. I get a piece, they get a piece. But the deal is, this is such a rare course, and you won't find anything like it out there. When I was doing the negotiation to sell this, I was given the requirement that, all right, Kevin, you've got to charge list price. No discounting on this. No, they cannot get it anywhere else. Don't discount this. You got to charge $399 for this. And we did, and we sold a ton of them. People love this. You might have heard of MPLS. Where do you actually learn that? SP Core, the Service Provider Core. You've heard of the ISIS routing protocol. Where do you learn that? You learn that in SP Core. In addition to doing a deep dives into OSPF and BGP and lots of other service provider issues. But I went back and I said, okay, can I have one exception? I promise I will charge full price, $3.99 all year long, but give me one exception. I do my biggest my biggest sale of the year around Black Friday, Cyber Monday. Let me give them a 25% discount during that time. And they said, okay, you can have that one exception. So this is the first time ever that I'm offering this at a 25% discount. And after the sale is over, contractually, legally, I got to go back to full price. So if you've ever been tempted to pick up the SP Core course, please do it right now, because we're giving you 25% off. And to make it, to sweeten the deal even more, is I'm going to throw in some extra training. I want to give you the our cybersecurity fundamentals training to get you going on cyber. I want to get you going on cloud computing. So we give you our Getting Started with Cloud Computing course. And since SP Core is such a deep dive into these routing protocols, I took replays from our live route and switch courses when that was in the previous version of NP, route switch. I'm giving you those courses for free, those replays. So this is nearly a $1,200 value. And with this 25% discount today and tomorrow, you can get it then tomorrow if you want to wait. You can get it for $299.25. I promise. This is the best price I've ever offered. And after the sale is over, I got to go back to full price. So now's the time to pick it up. If you'd like to pick it up, just go to kwtrain.com/service. Again, that's kwtrain.com/service to pick up this. It's been a super popular course for us. It's the Service Provider Core course, the Core Technologies, or CP Core for short. So again, that's kwtrain.com/service. All right, let's get into our final troubleshooting exercise of the day, and that is EIGRP. Here's our topology. You might notice that it is identical to the RIP topology that we had earlier. Now, I've actually got different routers spun up for this, but it's the same topology. So that diagram on screen, it should look very familiar to you. And let's go over to R1. There we are. That's R1 for our EIGRP topology, and it's the same deal. We're not allowed to use debug commands. We're not allowed to say show running config or show startup config. I want you to be able to give a series of show commands and figure out what's going on here, where we should have optimal pathing between the PC and the server. Every router should know about every network. And I'll get us started here. I'll start on R1 and I'll say show IP route. Does it know about all the networks? It very much does not know about all the networks. It has learned a grand total of 0 networks via EIGRP. So we got some serious issues there. Let's take a look at R2. What does it know, if anything? Show IP route. Okay, it's got a static route, but it still has learned nothing via EIGRP. Do I even have EIGRP configured? Let's do a show IP route on R3. And it's learned nothing via EIGRP. So obviously we got some serious issues going on here. Let's go to, we're here on router R3. Let's do a show IP protocols just to see, do I even have EIGRP configured? And I do. You see it right there. And let's go to R2 and give the same command and tell me if there's anything different here. Let's do a show IP protocols. So I'll let you look at that for a moment. This is R2. R3. Back to R2. Are you seeing anything? Go ahead and chat it in if you would. Somebody's asking, is there going to be a discount for Encore and an RC? Yes. If you come Friday, that's going to be our deal of the day on Friday. We're going to have our NP Enterprise courses on sale on Friday. Thomas says, the autonomous system number. And Frederico was saying the same thing. They're noticing that the autonomous system number on R2 is 100. The autonomous system number on R3 is 1,000. It's like the person that set this up, they fat fingered it and they put in an extra zero. It can happen. Okay. I agree with you. I think this one, let's see what R1 is, just so we make them all match. On R1, let's do a show IP protocols. Okay, it's also 100. So yeah, the odd router out here is R3. Let's go into R3 and let's just get rid of the existing EIGRP configuration. I'll say no router EIGRP 1000. And then I'll say router EIGRP 100. And just as a shortcut, I'm going to say network 0.0.0.0. Let's see, 0.0.0.0 with a mask of 255.255.255.255. That says every interface that has an IP address, I want EIGRP to advertise that interface. Let's see if anything is better now. Let's do a show IP EIGRP neighbors. Do I have a neighbor? I do not have a neighbor. So we need to keep digging into what's going on here. Again, let's do a show IP protocols. Take a good look at it. Let's go to the next router. Let's go to R2. Well, let's see. Yeah, you already see the output of the show IP protocols there. So let me just toggle back and forth between these. Do you see any problems here? That's R2, R3, R2, R3. One more time. R2, R3. Any differences that you're noticing? What do you think? Yeah, on Facebook, again, not going to try to pronounce the name, but yeah, the initials AS is saying it's K values. Yeah, look at this. Our K values on R3 are 10100. I think those sound like the defaults. On R2, they're 01100. Those are not the defaults. They're not matching up. And that's a requirement for EIGRP to form a neighborship. We've got to have matching K values, and clearly we don't have matching K values right here. So let's fix that. How do we fix the K values? Well, this is that's a command that has a little bit of confusion with it. So R2, that's the one that has the non-defaults. Let's go into router configuration mode for EIGRP Autonomous System 100. We all agree on that now. And I'm going to say metric weights. That's how we set our K values. Now here's where it gets confusing. You know that in this case, because we're not using named EIGRP where there's actually 6 K values, we've got 5 K values. So I would expect that we would just type in 5 values here. But if you use context-sensitive help, it says, hold on, before you give a K value, give the type of service value. Now, this is a quality of service thing. Do you remember with quality of service, with an IP version 4 packet, there are 8 bits making up what's called the toss byte, and that can be used to indicate the priority of a packet. And it wants us to say what is the value of that byte in decimal. Well, at this point, it does not matter because it says, yeah, only 0 is supported. It doesn't matter if you have what your toss value is. You can only put in a 0 there. But here's the problem. A lot of people put in a weight right there for like K1. It's not. It's always a 0. They say it's from the TOS value, But come on, it's always a 0. So just remember it's always a 0. And then we'll put in the defaults for the 5K values of 0. Actually, sorry, it starts at 1. 1, 0, 1, 0, 0. I think that's going to match up. Let's do a show IP protocols to see if that's matching up now. That, to me, looks a lot better. Do we have a neighbor now? Let's do a show IP, EIGRP, neighbor. Ah, great news. I am now a neighbor. Let's see, I'm on R2. I am now a neighbor with, R1. Oh, somebody said looks like network, or looks like we're missing some network statements on R3. Well, when I gave, let's do this. It says I'm routing for networks 0.0.0.0. That includes all possible IP addresses. Now, remember, here's another big point of confusion that people fall into this trap. They think if we give the network statement and then give a network and a mask, they think we're saying advertise this network. That's really not what we're doing. If I give a network statement and say network 192.1.5.0 and then I give a 24-bit mask, I'm not actually saying advertise that network. What I'm doing is I'm specifying an IP address space. And if I have an interface that is up, who has an IP address that falls within that address space, then that network statement is saying advertise that interface's network. Here, I'm giving all zeros, which encompasses all possible IP addresses. So if I have an interface that's up and has an IP address, I want to advertise that interface's network via EIGRP. So I would say that we do have an appropriate number of network statements right there. We just use sort of a shortcut. Now, on back to R2 for a second. On R2, if I do a show IP route, we did establish a neighborship, which was encouraging. We're now neighbors between R2 and R1, but there's in fact, let me do this from R1. I think this would be a better perspective. If I do a show IP route on R1, I've learned a little bit from EIGRP. I've learned the D means well, it's the dual algorithm, but that's what EIGRP uses. I've learned about 10.1.1.0. I've not learned about 10.1.2.0. So that's an issue. I wonder, I'm just curious, from R1, actually I'll go back down to R2. Because R2 does have an entry for that subnet to which the server belongs. Can I ping the server? Can I ping 10.1.2.200? Can I ping the server? I've got a route to that network. I cannot. Is it even up? If I go to R3, from there, can I ping 10.1.2.200? Yeah, I sure can. Interesting. So, what do you suggest I try next? I've got a couple of issues still going on here. If I do a show IP interface or a show IP EIGRP neighbor, I'm only a neighbor with R1. Anybody have any suggestions? Steve noticed something. Steve said packets are being dropped with the null zero route. Oh, interesting. Somebody went in there and created a static entry to say that those networks are that network goes to null zero. That, my friends, is also affectionately known as the bit bucket, which goes nowhere. That'll just drop those. So yeah, that's definitely an issue. So let's get rid of that. Great catch. I'm going to say no IP route. No IP route 10.1.2.0. Got a 24-bit subnet mask, 255.255.255.0. Okay, we got rid of that. That's better. But now I don't know about that network at all. And it's because it looks like R3 isn't talking to anybody. R3 has not formed a neighborship still with anybody. I think that's where we need to focus our attention next. If I say show IP protocols, or actually show IP EIGRP neighbors, I got no neighbors. If I do a show IP EIGRP, or actually just IP protocols, I corrected my autonomous system. I've got appropriate K values. I'm advertising all networks. Would you like me to go somewhere else and maybe give a different command somewhere? Oh, somebody said, can you go back and look at R1? Yeah, let's do it. R1, I'll do a show IP protocols. Oh, I'm seeing something there that's concerning. Does anybody notice a problem from this output? Who can spot it first? Some people are saying timers. Do timers have to match on neighbors with EIGRP, by the way? Actually, no, they don't. Timers do not have to match because they do with OSPF, but the hello and the dead timers mean different things with OSPF and EIGRP. So please follow me on this. With OSPF, neighbors have to have matching hello and dead timers. Because with OSPF, the hello timer says, I'm going to send a hello message to my neighbor every however many seconds. Let's say it's 10 seconds. My dead timer is going to say, if I've not heard from my neighbor within this amount of time, maybe it's 40 seconds, I'm going to consider my neighbor to be down. That's what the hello and dead timers mean with OSPF. It's different with EIGRP. With EIGRP, I'm saying with my hello timer, same thing. Every however many seconds, I'm going to send a hello message to my neighbor. But where it's different is with that dead timer or the dead interval. If I say 40 seconds, I am not saying, hey, Mr. or Mrs. Neighbor, if I don't hear from you within 40 seconds, I'm going to consider you down and I'm going to break our neighborship. That's not what we're saying. That's what OSPF is saying. EIGRP is telling that neighbor, hey, if you don't hear from me within this amount of time, then you can consider me to be down. It's almost like somebody's going in the big scary cave on the movie and they say, if you don't hear from me in 20 minutes, I'm probably gone. That's what EIGRP is doing. It's saying, consider me gone if you don't hear from me within this amount of time. It's not that I'm going to disconnect with you if I don't hear from you within this amount of time. And as a result, we don't have to, it's probably good practice to have matching timers, but it's not required. Let's see. Mirko's got it. Albert's got it. Steve's got it. Frank's got it. I'm just looking at some of the different chat interfaces we have here. Yeah, somebody else on Facebook has got it. Khalid has got it. Yeah. Notice that it says gig 0/2 is a passive interface. That means even though I'm advertising the network off of gig 0/2, I'm not processing any received EIGRP messages, and I'm not sending any EIGRP messages other than to announce that network. But I'm not receiving any EIGRP messages. So yeah, I think you're right. We should get rid of that. So let's go into global configuration mode and then into router configuration mode, EIGRP 100, and let's say no passive interface gig 0/2. And now let's see if we have neighbors. If I do a show IP EIGRP neighbor, great news. I now have a couple of neighbors. This is looking good. Let's just go around the tree and make sure that everybody can see all the networks now. If I go to R1 and say show IP route, can I see all the networks? See the network where we have the PC and the server. I think I do. Does anybody see one that I'm missing? I think we see all the networks there. Give a moment for anybody to chat in if they're seeing something else that we need to address, but I think it's looking pretty good. All right. Let's go to R2 and say show IP route. It seems to see everything. Nice. Does R3 see everything? Show IP route. Yeah, it does. I think we might be done. Let's go to our PC and let's do a trace route. And again, we want to take the optimal path. I'll say trace route to 10.1.2.200. That's our server. Our first hop should obviously be R2, and it is. The next hop should be R1 if we're taking the least cost path, and it is. The next one should be R3, and it is. And then the last one should be the server itself, and it is. Nice. Because EIGRP's metric calculation by default does consider bandwidth and delay. The bandwidth played into it, and yeah, we're in good shape. So again, congratulations. You have done an amazing job on solving 3 different, I think, somewhat challenging issues. And on another note, I said I was doing this little session today to test out the streaming service and the chat service for our big mega training on Friday. I think it worked pretty well. I was able to see chats on all the different interfaces. If you have any questions you'd like to ask now, go ahead and start. You can go ahead and chat those in. Again, I want you to know about that big marathon session. It's a 2-day free session on Monday, November the 25th, and on, Friday, November the 25th, and Monday, November 28th, from about 2 p.m. to about 5 p.m. Okay, it's going to be about 6 p.m. probably on Friday, to be honest, because we had a lot of demos to do. But yeah, that's Eastern time, and that's 5 hours behind UTC or GMT time. And to get signed up, it's free. Just go to kwtrain.com/2023. Any questions? Okay, great question. Marco's saying, Kevin, you can say, can you say what those K values mean exactly? Yeah, the K, if you go look at the, in fact, let me see if I can find it, because it's not one I'm going to remember off the top of my head, but let me look up the EIGRP metric formula. It is bizarre. Let's see, metric calculation. Let's see if I can find this. I'm just doing a quick Google of this. And this is from the Cisco Press website. So I'm going to share this out from the Cisco Press website. Let's see if I can make it a little bit larger. But here is, oh, is this a book? I was trying to see, am I one of the, I think, I was trying to see if I was one of the authors on that book. I may be, I'm not sure, maybe not. But here's the metric calculation, and you see that we consider bandwidth, delay, load, reliability. MTU, by the way, is there as a tiebreaker. It doesn't even show up in the formula. But let's say that with our default settings, where K2, 4, and 5 are all zeros. Some of these just disappear. Like reliability, not even concerned, it zeroes out. Load zeroes out because we've got a zero up here. Oh, by the way, you might say, hold on, Kevin. K5, if K5 is 0, something divided by 0 is not 0, it's infinity. Yeah, this formula is a little bit weird in that if you're dividing by 0, you don't say it's undefined or you don't say it's infinity, you just say it's 0. So it's an imperfect formula, but we can give different weightings to different metric components of bandwidth, delay, reliability, load, and MTU as the tiebreaker by adjusting those K values. But if you just plug in the default K values, it all zeroes out to the point where we're left with just bandwidth and delay. Great question. All right, any other questions? Somebody said, better not touch K values. Yeah, and Nick is reminding us of the acrostic that I've used for years. Big dogs really like me. The B in big reminds me of the B in bandwidth. The D in dog reminds me of the D in delay. Really reminds me of reliability. Like reminds me of load. And me reminds me of MTU. All right. Oh, yeah, I promised to give you downloads. I forgot about that. Sorry about that, folks. Let me give you those downloads I promised. Again, if you want to pick up our discount for our deal of the day that starts tomorrow, you're the first ones to see this. Go to kwtrain.com/service. This is the only time of the year where I'm allowed to discount this from the list price. You won't find anywhere like this on the marketplace right now. Now, here's the download I promised. To get those .yaml files that you can import into your CML or the CML sandbox that you lease for 4 hours out of the DevNet sandbox, just go to kwtrain.com/surprise. That's right, kwtrain.com/surprise, and there'll be a download button there where you can download that zip file. So kwtrain.com/surprise. Again, be sure and get signed up for Friday and Monday. Just one sign up is required. And it's, let's get back to it. It's kwtrain.com/2023. Take advantage of our deal of the day for the service provider training at kwtrain.com/service. And your download is at kwtrain.com/surprise. Let's see. Can we change bandwidth and delay per neighbor? Bandwidth is, no, you cannot change bandwidth and delay per neighbor, because if you look at the end-to-end path between a couple of routers, and maybe this link is 100 meg, this link is a gig, this link is 10 gig, the bandwidth is going to be the weakest link. And in my case, the example I just gave you, the weakest link is 100 meg. So the bandwidth is going to be a function of that. It's going to be that bandwidth divided by 10 to the 7th power is going to be your bandwidth number. Now, delay is cumulative. That's as we exit each interface based on the interface speed, it increments an amount of delay. And Giuseppe says, yeah, I got it downloaded. Thanks. You're very welcome. Oh, somebody's saying, why do we actually need that virtual link in the OSPF demo? Just the way OSPF works, we're not allowed, or it does not support an area that is not adjacent to the backbone area, which is area 0. That's the reason those were not being advertised. Because if you go in and look at the LSA types, as we're advertising from one area into another with the type 3 summary LSAs, it's just not going to do it. If it's a non-backbone area, those won't be advertised, or it won't be advertised beyond that adjacent area. It won't be advertised into area 1. Let's see. Does that apply to controller software like SDN? Not sure exactly what we're asking there. Will this session be on YouTube later? I'll leave it up for a few days. Obviously, it's a test. I'm promoting this thing happening Friday, so yeah, I'll take it down pretty soon, but I'll leave it up for a little while. Probably take it down next week. All right. Let's do one more question. I think the EIGRP neighbor is not showing up between R2 and R3 in that last troubleshooting. Oh, is it? Oh, I didn't realize that. Let's go see. And let me take my face off the screen once again. So the question was, don't think we have a neighbor between R2 and R3. Let's see. Show IP EIGRP neighbors. Do I have a neighborship with R3? Oh, you're right. I totally overlooked that. You are right. Well, let's do some troubleshooting together then. Let's see. Show IP interface brief. Let's make sure I physically have connectivity to it. Show IP interface brief. That link going down is 198.51.100.0/30. So can I ping the other end? Can I ping 198.51? Huh. Interesting. Oh, I'm sorry. I'm on R2. My bad. I'm on the wrong router. R1 show IP EIGRP neighbors. Let's see. You were asking about between R2 and R3. Okay. It was R2 and R3. Excuse me. So okay, R2 and R3. We got something up there that we didn't identify. So great catch there. So R2, can I ping 203.0.113.2? Oh, I mistyped that. Can I ping 203.0.113.2? Yes, I can. Okay, great. So let's do a show IP protocols. Anything weird happening with that interface? Anybody see, oh, no worries at all. Okay, we're getting a little bit of spam in here that we're going to have to kill off. Excuse me while I hide that. This is not a meet new friends environment, so we're going to get rid of that. Sorry for that, everyone. That's just one of those things that happens on YouTube sometimes. It's kind of, I don't know. It's kind of annoying, but on Friday I'll have somebody in the background that will be getting rid of things like that. Let's see. Anybody have any suggestions? Somebody says, let's show IP EIGRP interface. I like it. Show IP EIGRP interface. Okay, those interfaces are up. Let's do interface gig 0/3. Any other command you want me to try? Let's see. Any other suggestions? Let's see. Somebody says 113 star. I'm not sure what we're talking about there. Yeah. I thought we'd addressed everything. The errors I injected into this is I set up a passive interface. I don't think we still have a passive interface, do we? Show IP protocols. Do I have a passive interface? No, I don't seem to. Am I routing for the correct networks? No, I'm not. Oh, look at that. Yeah, it looks like I'm not routing for the right network. Yeah, it looks like I'm missing a network statement. How about that? Yeah, great catch. I didn't even realize that. So let's say router EIGRP 100 And I'll just do what I did earlier just to make it quick and easy. I'll say 0.0.0.0.255.255.255 because I want everybody participating in it. Let's see. What did it not like about that? Let's see, network. I'll just put it in. I'll say 203.0.113.0. The wildcard bits would be 0.0.0.3. Show IP protocols again. It now says that we are routing for that network. Let's see if we have a neighborship. Show IP interface or show IP EIGRP neighbor. Oh, much better. So yeah, I totally missed that. Thank you very much. The issue was, if anybody missed it, we had a missing network statement on R2. I didn't even notice it, but great catch from our students. All right, folks, we're going to go ahead and wrap it up for the day. Again, I would love for you to join me on Friday. Let me put that link back up. If you would join me on Friday and Monday, we're going to have a big marathon session where we're going to be doing things like setting up AWS. I'll be configuring MPLS. We'll be doing password recovery. And that's just Monday. We got lots of other stuff. Excuse me, I keep saying Monday. That's going to be Friday. We got other things. We got cybersecurity, and we've got network programmability coming up on Monday. So it's going to be just a jam-packed week of training. And I thought we'd kick it off with sort of a surprise bonus session today. Thanks for joining us, everyone. I'll make sure this link is up on YouTube for the next few days anyway, if anybody wants to go back and